Hello, namaskar and welcome. Now, this time we are going to solve an LPP which we have already formulated as an LPP in a previous lecture. The case with two mines. Yes? But let me first read the question for your ready reference. A steel company has two iron mines having different production capacity. The raw iron is classified into three categories: high, fair or medium, and low according to the quality. The factory of the company requires at least 12 tons of high grade iron. This is the constraint based on this information. At least 8 tons of medium or fair grade iron. This constraint is based on this information. And at least 24 tons of low grade iron per week. Yes? Okay. Yes, please. At this time of reading, please keep the formulated problem with you, which we have already formulated in a previous lecture. The daily expenditure of the first mine is rupees 20,000 per day and the second mine is rupees 16,000 per day. Daily expenditure means per day. The daily production of raw iron in the two mines is as follows. Mine 1, high grade 6, medium or fair grade 2, low grade 4 tons. Yes? Daily production. Mine 2, 2 tons of high grade, 2 tons of fair grade and 12 tons of low grade. Okay. To minimize the cost of operations, for how many days each mine should work in a week? In a week, that means a week has 7 days. That means no mine can work for more than 7 days in a week. These two constraints are based on this information. Now, we have already formulated, and x1 and x2 are number of days mine 1 is working and mine 2 is working in a week respectively. Okay, these are the constraints. Let's first simplify them. Equation will be 6x1 plus 2x2 equals to 12. 2 points to draw the straight line of this equation. If x1 is 0, then 2x2 equals to 12, so x2 is 6. If x2 is 0, 6x1 equals to 12, so x2 is 2. Inequality part will be 6x1 plus 2x2 greater than 12. If x1 equals to 0, 2x2 will be greater than 12 and hence x2 greater than 2. Sorry, 6, not 2. If x2 takes value 0, then 6x1 will be greater than 12 and that means x1 greater than 2. In this case, the equation will be 2x1 plus 2x2 equals to 8 and the 2 points respectively will be 4 and 4. The inequality will be 2x1 plus 2x2 greater than 8. If x1 is 0, that means 2x2 greater than 8 and that means x2 greater than 4. If x2 takes value 0, then 2x1 greater than 8 and hence x1 will be greater than 4. In this case, the equation will be 4x1 plus 12x2 equals to 24 and the 2 points will be 24 divided by 12, 2 and 24 divided by 4 it will be 6 and the inequality will be 4x1 plus 12x2 greater than 24. If x1 takes value 0 then 12x2 will be greater than 24 and that means x2 will be greater than 2. If x2 takes value 0, then 4x1 will be greater than 24. That means x1 greater than 6. In this case, x1 equals to 7 or x1 less than 7 will be there. These are the constraints based on number of days of a week. For any value of x2, x1 is 7 or less. That means the line will pass through x1 equals to 7 and the line will go parallel to x2 axis. Similarly, in this case, x2 is 7 or less than 7, and for any value of x1, x2 remains 7 or less. That means the line will pass through x2 equals to 7 and it will go parallel to x1 axis. Since the maximum value required on both the axes are 7, I can draw the sketch of this graph in this very small area also. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Okay, now first x1 equals to 2 and x2 equals to 6. 2, 6. The line passing through these 2 points. Yes, 6x1 plus 2x2 equals to 12. And x2 greater than 2, that means 2 or more, x2 6 or more, so outer side. This one is 4 and 4, x1 4, x2 4. The line will be something of this kind. 2x1 plus 2x2 equals to 8. x1 greater than 4, x2 greater than 4, okay, outer side, opposite to 0, x1 6 and x2 2. This kind of line should be there. 4x1 plus 12x2 equals to 24. x1 greater than 6, yeah, 6 or more, x2 greater than 6, 2 or more will go outside. Yes, this and this. For these three constraints, this is unbounded solution, but there is a restriction. Number of days of work in a week, that means they cannot exceed 7. So we have two constraints with less than or equal to sign. Less than or equal to. I'm sorry for that wrong sign. And for this, the line will pass through x1 equals to 7 and parallel to x2, x1 equals to 7, and since number of days cannot be greater than 7, so it is less than 7, so inner side the constraint is 7 or less. Similarly, the constraint x2 7 or less will be like this. So feasible region is this one. Okay. Now let's go for the corner points. We have 1, 2, 3, 4, 5, 6 and 7 corner points this time. A is 6 and 0. This is B, and B is 3 and 1. This is C, it is 1 and 3. This is D, it is 0 and 6. This is E, it is 0 and 7. This is F, 7 and 7. Both the mines should work for all 7 days a week. And this is G, 7 and 0. Only mine 1 work for 7 days. Only mine 2 work for 7 days, and so on. Now let's check at which point the objective function takes its minimum possible value. And for that purpose, we need to substitute the coordinates of all these corner points into our objective function. Okay, corner points, there are 7. coordinates of the corner points. And value of z equals to 20,000 x1 plus 16,000 x2. Okay. Corner point A 60, that means 20,000 into 6 plus 16,000 into 0, that is 1,20,000 plus 0, that is 1,20,000 rupees. Okay, B. B is 3 and 1. 20,000 into 3 plus 16,000 into 1, that is 60,000 plus 16,000, 76,000. Remember, this is minimization problem. C 1 3, 20,000 into 1 plus 16,000 into 3, that is 20,000 plus 48,000, 68,000. D 0 and 6, 20,000 into 0 plus 16,000 into 6 equals to 0 plus 96,000, that is 96,000. E 0 and 7, 20,000 into 0 plus 16,000 into 7, so it is 0 plus 112,000. F 7 and 7, 20,000 into 7 plus 16,000 into 7, that means 1,40,000 plus 1,12,000, and that is 2,52,000. G 7 and 0, 20,000 into 7 plus 16,000 into 0, that is 1,40,000 plus 0, 1,40,000. Yes, since this is minimization problem, the minimum cost is rupees 68,000, and that is at point C. 1 and 3 are the coordinates, that means x1 equals to 1, x2 equals to 3. Yes, and if we substitute these two coordinates into the remaining 3 or in all the 5 constraints, either equality part or inequality part should be satisfied. Now this is assignment for you. Substitute these values of x1 and x2 respectively into all 5 constraints and check that all the constraints are satisfied, either equality part or inequality part. The interpretation is x1 equals to 1, that means mine 1 should work for 1 day in a week. x2 equals to 3, that means mine 2 should work for 3 days in a week, so that the required production is obtained, minimum required production is obtained and at the minimum possible cost, and minimum Z, that means minimum operating cost, comes to rupees 68,000. Okay, so ultimately we solved a problem in 2 parts. In first part we formulated the linear programming problem for a managerial problem, and since it has only 2 variables, now in this lecture we solved the same problem which was formulated by us earlier through the graphic method. That's it. Thank you very much.